So let's talk about what all is happening this week, because you do have your first test is this week. So the sections that are covered this week are the review for test 1, which I'm going to start today. We won't get through all of it. We'll finish it on Wednesday. Then test 1 is also due on Sunday at midnight. And then 7.1 and 7.2, which is the start of the next section of work, will also be due on Sunday. So we won't get to those 2 sections until Friday, but they're both real short. There's like 5 and 8 questions, and they're not hard. So let's talk about how the review and the test work. Because everything you've had so far has been in Math Lab as a homework assignment, and all the homework assignments are the same, right? You get to work each problem as soon, and you can check your answer as soon as you're done working the problem. If it's not right, you get another chance. If it's not right, you get another chance, and then it'll say final check. Even if you get it wrong, then you can click on similar question, and it'll just change the numbers and give you another question like that, and you'll still have a chance to get it right. You can work it 100 times until you get it right, okay? Now, the review is set up different. The review, you have to work all 25 questions and submit the quiz before it tells you what you got on the whole assignment. It doesn't tell you each individual problem like it does in the homework. So once you submit the quiz, it'll tell you your score. You can click on review your results, and it'll tell you every question that you got wrong or right. You can click on the ones that you got wrong to see what kind of problem it is. So the ones that you got wrong, if you click on it, it'll tell you the correct answer and then also what you put. So you may look at what you put compared to the correct answer, and it may just be that you forgot to put your negative in, or you divided wrong at the end or whatever. A lot of times you'll be able to see what you did wrong by comparing the right answer with the wrong answer, okay? Next to the problem that you click on in the review, when you're reviewing your results, it'll have something next to it like this. That tells you what section, what chapter and section that problem came from. So this will tell you that it came from chapter 2. This will tell you that it came from section 3. So I'm going to open up all of the homework assignments from everything we've done so far, and make them due this Sunday. So that way, when you're doing your review, you can go back to this, like section 2.3's homework, and look at more problems like that, okay? Now, this number right here is the actual number of that problem from the book, the actual, like the e-text that you can access in my Math Lab, the e-text. If you wanted to see that exact kind of problem, you could go to that in the e-text, okay? That's a lot of work. So these numbers right here are the most important. That means you're struggling, especially if you miss 2 or 3 problems from 2.3. That means you need to go back to that homework assignment and review some of those kind of problems, okay? Now, the other thing about the review is you have infinity amount of times to work it. So say you work it today after we just go over half of it, and you make a 65. Doesn't matter. As soon as you go back in and rework it, and you get it, you work it the second time and you get an 80, that 80 completely knocks the 65 out of the grade book and replaces it with an 80. If you take it again and you get a 90, now the 80 is knocked out and you get a 90. So see what I'm saying? It's only going to take your very highest score. So say you worked it the first time and you got an 85, then you worked it again and for some reason you got a 70. It'll just keep the 85. It's not going to count the 70. It's not ever going to replace a higher number with a lower number. Okay? So there is no downfall to taking it multiple times. You don't have to worry about getting lower, because if you do get lower, it's just not going to count it. So the point of doing the review is to do it until you are comfortable with the material, because the test you only get one time to take. The test and the review, though, are very similar. You'll see how similar they are to each other. Pretty much the only thing that's going to change are the numbers, right? So if you've done the review 5 times and the last time you took it, you pretty much flew through it because you've seen all those kinds of problems several times again, then you're ready to take the test. So don't take the review one time and get a 55 and then go in and take the test. 55 on the review means you're not ready, right? It means you need to take it again. You need to do that review again. Okay? So are there any questions on that? Same as transitional. Same. Oh, except y'all took paper sense. Okay, so we're only going to be able to get through about half of the review today. Then we'll finish it up on Wednesday. But again, I would recommend taking the review in my math lab sometime between now and Wednesday, and then just focus on the front end of it, right? The ones that we've covered. Then after Wednesday, after you've seen the review of the second half of the review, then take it again. Okay? And the second half of the review is the latest stuff that we've covered, so it's probably the most recent on your mind anyway. You may do fine on the second half, because it's the most recent stuff we've gone over. Probably the stuff we did last week. Okay, so let's look at the problems you're going to see on the review. The first group of problems are going to be all the way back from the beginning of the semester when we were doing a lot of graphing. And it's going to say graph by plotting points. So let's see. I have 6y. It says graph the equation by plotting points. 6y plus 3x equals 6. Now, remember, at some point, hopefully everybody has gotten a TI 83 or 84, preferably, calculator. Because if you're going to graph using plotting points, the easiest way to do that is to use your calculator, right? Your calculator will give you a table of points to choose from to plot. You just have to tell it what to do. Now remember, every time you're going to graph in a calculator, you're going to go to that y equals button, right? That's where you do all your graphing, is the y equals. So if I'm going to do that, I need to know what y equals, not what 6y plus 3x equals. So if your equation that you're using to graph doesn't already have the y by itself, that's your first step, is to solve it for y. So let's see, if I'm going to get this y by itself, the first thing I need to do is subtract that 3x from both sides. So now on the left, I have 6y equals, on the right, these two terms are completely not alike, right? One's an x and one's not. So I can't put them together, which means I just put them separately on the right side of the equal sign. It doesn't matter even which term you put first. You can either put negative 3x plus 6 or 6 minus 3x. It all means the same thing. So I'll just put the x in front because I always like to put the x in front. So negative 3x, bring down your plus 6. Still working on getting the y by itself. I need to divide everybody by 6. So now there's my y by itself. Negative 3 over 6, that will reduce, right? Because 3/6 is 1/2. So that'll reduce to negative 1/2 x plus 6 over 6 reduces to 1. That's what you're going to put in your y equals. right? So now if you'll go to your y equals and put that -1/2 x plus 1. So -1 divided by 2, right? That's what's going to give you the -1/2. X, remember x is this button here, plus 1. Now, what I really need is the table. But before, remember MathLab, when you're graphing, the first thing it's going to ask you to do is tell the graph what shape you're about to draw. Are you going to make a U? Are you going to make a line? Are you going to make a V? It's going to ask you that to tell it that first. So always hit the graph button to see what shape you're about to draw. Then hit second table. There's your points to choose from, right? On the table, choose any 2 points that you want. That's all you need to graph a line is 2 points. So I can pick any 2 points I want. Let's just see. I'm trying to stay away from decimals. Anything where the y has a decimal, I don't want to mess with that. It's too hard to plot that. So let's see. I'll do -2, 2. And again, just picking out out of this table. I'll do 0, 1. Since it's a line, it doesn't matter which point you plot. So let's see, -2, +2. So my x is -2, which means I'll go to the left 2. My y is +2, which means I'll go up 2. So left 2, up 2. Now remember, in MathLab, when you're graphing, remember up here in that yellow toolbox, it always tells you where your cursor is up here in that corner, so you can kind of see, because sometimes it's kind of fidgety, right? So -2, 2. And then 0, 1. So left and right, 0 for my x, up 1 for my y. And remember, once you put that second point in my MathLab, it'll automatically connect those points for you. Okay? Number 2. Y equals x squared plus 3. So this is already solved for y, right? The y is by itself. Since I'm graphing, I can just go straight to my y equals now. Go to your y equals, clear out your last graph, put in the x, hit your x squared button. Oh, whoops, not that one. Your x squared button. Oh, what's going on? Let me clear that up. X squared, and then plus 3. Now, let's graph this to see what shape that's going to give me. Since it's an x squared shape, that's that parabola, that U shape. So remember, you're going to have to tell MathLab, I'm about to draw a U. And then hit your second table and pick any 2 points you want, right? Again, MathLab will just require you to plot 2 points to draw this. Pick any 2 points that you want. Let's see, I'll do 0, 3, and 1, 4. MathLab will draw the U just from those 2 points. All right, that first point at 0, 3, which means left and right, 0 for my x. My y is +3, so I'll go up 3. Another point at 1, 4, which means to the right 1 and up 4. Now remember, MATLAB, since you've told it that that's going to make a U, it's going to do that for you. Since I'm freehanding this, I want to see where the other side of the U is happening. What's happening on the other side of this point right here, right? I can tell from my chart, or from my XY chart, that I'm going to have another point at -1, 4. And the reason I'm choosing this point is because I see that those Y's are the same. So that's where the mirroring is occurring, right? So -1, 4 would be to the left 1 and up 4. Again, you won't have to do all that in MATLAB because it'll do it from 2 points. Number 3, another graph. Y equals the absolute value of x minus 2. Now here, again, the y is by itself. So that means I can go straight to my y equals. Now remember where the absolute value button is in your calculator, because that's what I need to do. I need to make absolute value bars and put the x minus 2 inside of it. So hit your math button. Once you hit math, go over to the right 1 to number. Absolute value is the very first thing under that. So hit enter, and that'll give you your absolute value bars to start typing in. So I need to put in an x minus 2 inside there. So x minus 2. Hit graph. What kind of shape is this going to make? Absolute value graphs always make a V. Now, the difference between the absolute value graphs and the other graphs that you put in MATLAB is that once you tell it you're drawing a V by checking that tool out of the toolbox, it's going to tell you a very specific point to plot first, not any point. It makes you plot the vertex first. The vertex is that point right there where the V makes a point. So I have to plot that point first, which looks like it's to the right 1, 2. So it's going to be at that point where the X is 2. So when I go to second graph or second table, the first point I need to plot is that this one right here where my cursor is, where the X is 2. So I'm going to plot 2, 0, and then any other point. Let's see, I'll do 1, 1, and then I'll also do the other side of it, which is 3, 1. So just like the parabola, just like the U shape, the V shape, also at some point the Y's are going to match each other. That's the mirror. So remember, you have to plot the vertex first. So I have to do 2, 0 first, which is to the right 2, and then up and down 0. So I just put it right there on that x-axis, 2, 0. Now MATLAB will only make you plot one of these. I'm just going to plot both of them so you can see either side of the V. 1, 1 will be to the right 1 and up 1. And 3, 1 will be to the right 3 and up 1. So that's where the V occurs. Okay, number 4 talks about whether a correspondence is a function or not. Okay, and it has to do with the domain and the range. A correspondence, or any kind of relationship on a graph, it is a function if and only if each element in the domain only corresponds to one element in the range. So this is going to give me a list of numbers in the domain and a list of numbers in the range. For it, the answer to be yes, it is a function, each one of the numbers in the domain can only have an arrow going to one number in the range. So let's look at what this looks like. It gives me a group of numbers in the domain, -1, 1, and 8. Then it gives me a list of numbers, actually just one number, in my range, which is 2. Then it draws arrows on to what number in the range that each one of these elements in the domain goes to. The -1 goes to 2. So check it. Does -1 go to one number or more than one number? It only goes to one number, right? The 1 also has an arrow going to the 2. But check it. Does the 1 go to one number or more than one number? It still only goes to one number, right? It only goes to 2. What about the 8? The 8 also has that arrow that goes to the 2. But if I'm looking at this 8, how many numbers does it go to? Just one. So you don't ever see one of the numbers in the domain go to 2 separate numbers. So yes, this is a function because each element in the domain only goes to one element in the range. So yes, it is a function because of that reason. Each element in the domain only goes to one element in the range. Okay, so that's the answer to that one. I'm just going to show you what it would look like for a no answer and why. Because sometimes it's easier to understand this if you see the other situation. So what if I have a domain and a range and my arrows went like this? Let's say -5 went to 3. And that's all it went to. It would still be a function, right? -5 only went to one number. Let's say the 6 only had an arrow going to 7. I'm still okay, right? This element in the domain only went to one element in the range. But let's say the 4 went to -1 and to 7. That's what would make it no. It's not a function because where does the 4 go to? It goes to -1 and 7. That's what makes it not a function. All right, the next thing we got into was it gave us a function written out. It says for where f of x equals 3x squared minus 4x. And it asked me to find 3 things. The first thing it's going to ask me to find in this problem is f of 0. means to go to this function, and everywhere you see an x, it wants you to plug in a 0. So let's see, I'll have 3 times 0 squared minus 4 times 0. So again, replacing the x's with zeros. So let's see what happens here. Remember, you got to do your exponents first. So 0 squared is still 0. So I still have 3 times 0 minus 4 times 0. What's all that going to turn into? It's all going to stay 0, isn't it? Because 3 times 0 is 0, and 4 times 0 is 0. So that answer would just be 0. It's going to ask you to do that 2 more times with 2 different numbers. The next number on this problem says find f of -1. So still using the same function. This time I'm going to replace the x's with -1. So I have 3 times -1 squared minus 4 times -1. Exponents first. It's more important on this one than it was on the last one. Everything just turned to 0 over there. But you have to do this exponent first. -1 squared. If you are squaring something in your calculator that's negative, what are you going to put around it? Parentheses. Right? So -1 squared is +1. So this says 3 times 1 minus 4 times 1. I mean, what's that? Not 1. -1. 3 times 1 is 3. What does this turn into, though? -4 times -1 is +4. And 3 plus 4 is 7. So f of -1 turned into 7. I'm just going to ask you to do it one more time. So f of 2. Now, before I do this one, I will tell you this. MathLab does give partial credit. So if you miss one out of these, it doesn't mark the whole thing wrong. It'll give you 1/3. It'll give you 2/3 credit if you miss one of them. Okay, so finding f of 2. So replacing the x's with 2's. So 3 times 2 squared minus 4 times 2. Again, exponent first. So 2 squared gives me 4. So I have 3 times 4 minus 4 times 2. Three times 4 gives me 12, minus 4 times 2 is 8, and then 12 minus 8 gives you 4. All right, number 6. So 6 and 7 are more graphing, just like we did on problems 1, 2, and 3. But remember on problems 1, 2, and 3, we got to pick our points that we wanted to plot. These give you, that's back when, remember it gave us those little charts to fill in? So it's going to give you the charts to fill in and tell you the numbers it wants you to use for X, which is fine. They're still in our table on the calculator. Okay, number 6, f of x equals -4 plus the absolute value of x. So since the y, right, this is the same thing as saying y. is by itself, I can go straight to my y equals and put that in so that I can just use the table from my calculator to complete the chart. So go to your y equals, clear it out from the last problem. So you have -4. Remember, don't forget your negative button is down here below the 3. So -4 plus the absolute value of x. So remember, absolute value is under your math button. Math over 1 to the right to number. There's your absolute value. And then put the x in the absolute value bars. And if you want to, get out of them. So let's graph it to see what our graph's going to look like. It's going to be a V shape, right? All absolute values make V's. So it's going to, since it's the V, it's going to make me plot the vertex first. So remember, the vertex is this point right here. So let's look at our table and see what we think this point is right here. So go to second table. And remember, it gives us the numbers it wants us to use. It wants us to use. It tells us f and then f of x, not f, x and f of x. And it wants me to use where x is -2, -1, 0, 1, and 2. So again, I just go to the calculator and use those numbers from that table. Where my cursor is right now is where I start, right? That's where the x is -2. So just fill out the chart. -2 goes with -2, -1, -3, 0, -4, 1, -3, and 2, -2. So out of these points, looking at those, where do you think that point of the vertex occurs? It occurs where on either side of that point, the y's start matching. So right here is where the y's start matching. This right here is going to be your vertex. Okay, and again, you can look at the graph and you can see that right here, that 0, -4 is the point of that V. So you're going to plot that point first. So this point first, 0, -4, left and right 0, down 4. And then I'm going to plot the 2 points on either side of that. Okay? Once you plot either one of those, the math lab will draw the V for you. So -1, -3. So to the left 1, down 3. And then 1, -3. So to the right 1 and down 3. And that'll draw your V. Number 7. Graphing this time. F of x equals -x² minus 5. So it wants me to do the same thing. It gives me the same f of x chart. And it actually even gives me the same numbers it wants me to use for x. -2, -1, 0, 1, and 2. So the first thing you're going to do is complete that chart. So we'll go to our y equals, clear it out. Type in -x² minus 5. So what shape is this going to make since it's x²? Whoops. Enter. Why do oh, hit the wrong thing. Graph. It's going to make a U shape, right? It is upside down, but it is a U. So let's go to second table and do our numbers. And again, my cursor is right there on that -2. So I'm going to fill out the rest of my chart, starting with -2, -9. -2, -9, -1, -6. 0, -5, 1, -6, and 2, -9. Again, it's a U shape, which means it's going to start mirroring, right? So I can plot any two of these points. I'm going to plot where I know I'll be able to start to see the mirroring. And how do I know that? Where my y's are going to be the same. So I'm going to start in the middle of those at that 0, -5. So left and right, 0. Down, 1, 2, 3, 4, 5. Then I'm going to do a point on either side of that. -1, -6, which would mean to the left 1 and down 6. Remember, this U is going upside down. The other side is at 1, -6. So to the right 1 and down 6. All right, number 8. So earlier on, it asked us if a relation was a function or not, and it gave us a list of elements or numbers in the domain and a list of numbers in the range. And it was a function if each element in the domain only went to one element in the range. But what if it doesn't tell us what the domain and range are and just gives us a visual picture of what it looks like? This is where we use that vertical line test. Remember what the vertical line test says. The vertical line, which is the one that goes straight up and down, if you draw it through your graph and it only touches it once, then yes, it is a function. If you draw a vertical line anywhere on the graph and it touches your shape more than once, then it is not a function. It would mean that what that would mean is if you wrote out the domain and the range, you would have one element in the domain going to more than one element in the range. It's just a visual picture of it instead of seeing it laid out as domain and range. So on number 8, the graph looks like this. A y-axis, x-axis, and then the shape of the graph looks like this. So, if I can draw a vertical line anywhere on this and touch the graph more than once, then it is not a function. What if you draw a vertical line right here? How many times does it touch that shape? Once here and once here. So it touches it more than once, which means this just doesn't pass the vertical line test. It touches it more than once, so no, not a function. Again, sometimes it's easier when you see the other way around. What makes a yes answer? Let's say you have a U shape, but it's like that. So this one, it doesn't matter where I draw a vertical line, it would never touch this U more than once, right? It would only ever touch it one time. So that's what, yes, it is a function would look like. Okay, number 9. All right, we're going to work 9 and 10, and then we're going to do the rest on Wednesday, because I won't have my long spiel at the beginning about the review and the test. Now, this number 9, if you'll remember back when we did this section, talking about domain and range and things like that, it was much easier to read your graph to answer the questions than look at my free-handed drawing to answer the questions, because my free-handed drawing is not as exact as my MathLab's computer-aided drawing, right? You'll be able to see all the hash marks and everything. So let's see, I'm just going to do the best I can. So it looks somewhat like this, and it's going to ask you 4 different questions about this. Okay? It's going to say find f of a number. Then it's going to ask you for the domain of this graph. Then it's going to ask you to find the the x values when y equals a number. Then it's going to ask you to find the range. Okay? Let's do domain and range first. So this is going to kind of break it up into different ways than the order that it asks you on there. But I want to talk about domain and range of this first. And then do the other parts of the question. So remember, the domain is what are the x values of your function or your relation or your correspondence. The x values, what can they be? So if I'm looking at this, this is your x-axis, right? It goes left and it goes right. So when I'm asking you to tell what is the domain of this absolute value, right? It's an absolute value graph since it's a V, and it wants to know what the domain of it is. That means how far does it go to the left and right? In other words, how much of that x-axis is it going to cover? Well, look at your graph. Look at that V shape. What is it doing from here? It's going to the right. That arrow means it's going to the right forever. What is it doing on this side of the vertex? It's going to the left forever, right? So at some point in time, it is eventually going to cover all the way to the left and all the way to the right without leaving anything out, right? Which means the domain is all real numbers. It covers the whole entire x-axis at some point. That's why it's going left and right forever. The range is different because what does the range mean? It's talking about your y values. The y-axis is the one that goes up and down. So it wants to know how far does this graph cover of the y-axis. So let's see. It comes down to here, but then what does it do after here? It turns around and shoots back up, doesn't it? What does it not do after that right there, after that vertex? It doesn't ever go below it, which means it's not going to cover the entire y-axis. It's going to go up forever, but then it's going to, this is the lowest point it's ever going to go, right? It's not ever below that. So what I need to do is find this lowest point and say, what is the y value there? Well, what is the y value there? I don't care what the x is. I'm not talking about domain. I'm talking about range, which is y values. So if I came over here, I went to the right 4, but did I go up or down at all? No, which means my y value is 0. The y values of that V shape will never be below 0. That's the very lowest point, which means my range covers from 0 up, right? It goes up. My y values are both on either side of that going up from that 0, which means I want to say the range is y is greater than or equal to 0. All the numbers above 0 and above. So greater than or equal to 0. Now, the other two parts of this question say find f of 2 is one part. The other part says, what are the x values when f of x equals 1? So these two things. So this is the part where it's going to be easier to look at your exact computer drawing. Okay? Now remember, you do have a little magnifying glass to the top right of your graph in MathLab. I think it's up over here somewhere, where you can magnify your graph to make it as big as you want so you can see things clearer. So let's see, where f of 2, let's see, what number is always represented inside the parentheses? That's your x. So what it wants me to do is go over and find where x is 2. Here's 2 on my x-axis. So think of an imaginary vertical line going through that. Where does it touch your graph? It touches it, that imaginary line would touch it right here. That's where the x is 2 on my graph. So what it wants to know is what is the y value that corresponds to that point? What is the y value there? Well, where does this line up with on the y? It also is 2. Okay, so f of 2 equals 2. Where x is 2, y just so happens to also coincidentally be 2. Now, the last part of this problem, and remember, you will get partial credit for getting part of this right, if you only get part of it, says, what are the x values when y, right, this is the same thing as saying y equals 1. So where does y equal 1? Y equals 1 right here. So think of an imaginary horizontal line right there. Where does that horizontal line touch your absolute value graph? Touches it twice, actually. So there's going to be 2 x values that correspond to this because it touches it here and here. So let's see, I need to know what are the x values at those 2 spots. Well, let's see, where does this one line up with the x? Looks like it lines up with 3. And where does this one line up with the x? It looks like it lines up with the 5. So 3 and 5 are the x values when y equals 1. All right, last one, and then we'll wrap this up on Wednesday. This is also going to be a domain question, but instead of giving us a picture, like this one, and asks us the domain, it's going to give us just the written out function, not a graph. Now remember, when we did these problems, when you were finding the domain, you were actually looking for anything that x could not be. Because once you found that, then the domain would cover everything else except whatever the restriction was. And when we had a fraction with an x in the denominator, that gave us a restriction because we know that there are certain things that can't be in the denominator of a fraction, and one of them is 0. This right here, the denominator cannot equal 0. So that's exactly what you want to find. 2 minus 9x cannot equal 0. I need to see what makes that happen so I can leave whatever that number is out of my domain. So solving for x, let's see, this is a positive 2, right? The negative goes with the 9. So since that's a positive 2, I'm going to cancel it with subtracting 2. So now I have negative 9x cannot equal negative 2 over there, divide by negative 9. So now x cannot equal, that negative over a negative turns it to positive 2/9. So x can be any other real number on the number line, any other number on the number line, it just can't be 2/9. So that's what you say. It's multiple choice. So you would say x is a real number and x cannot equal 2/9. All right. We will wrap this up on Wednesday, but remember, you can go ahead and knock out a chance on your review. Now remember, it will be timed at 75 minutes so that you will get used to doing it. Like if I gave the test in class, y'all would only have 50, but in a normal Tuesday, Thursday class, they would have 1 hour and 15 minutes to complete it. So that's why it's timed at 75 minutes. So it's to get you used to that. All right, any questions? All right, see y'all Wednesday.